Hello everybody, welcome to yet another video by JFB, and in this video I'll be explaining the final basic logic gate which you need to know, and that is the AND gate. And don't worry, if you don't know what these other gates are, or this is the first time you're watching this series and you don't know what the AND gate is, but you have a brief introduction of what logic gates are, this video is okay for you because I won't even state those other logic gates. So what is the AND gate? The AND gate is represented in computer science or any other physics course you take concerning electricity like this, something like that. Then it has some input wires going through it, so it has two inputs, and like any other logic gate, it always produces one output. So that's how the AND gate is represented. Let me try to draw a better diagram. If it doesn't become better than this, then yeah, we'll stuck with that. So it's something like that. The curve it in front, then it gives a single output, and at the same time it takes in two inputs. Don't ever try to make this side like a complete square. No, 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 no. This side is always like a curved square to represent AND gate. So this is the AND gate. This thing here is the AND gate. Then these are the input wires. So all logic gates always produce one output. So like any other logic gate, it produces one output. Now let's try to break down how the AND gate works. The AND gate obeys one principle called everything. What do I mean by everything? The AND gate will only give you a logical output of 1 when you give it everything. So by everything I mean like when you satisfy its needs, like it says, if you give me all the inputs which I need, then I'll give you a logical output at this end. To show this in a more brief explanation and a more understandable way, we're gonna draw what we call a truth table. What is a truth table? A truth table is simply a table in which we can track the inputs given to a logic gate and also track its outputs. So a truth table is just columns and rows, whereby now we just track the inputs and the outputs of any logic gate. Actually, any logic gate that's built there, you can just take a note of the truth table and you can be tracking its inputs. Actually, even the truth table can be used to determine what type of logic gate you're actually using. So if somebody was to just give you a truth table, you can easily determine by observing the patterns of how that logic gate was working, what that logic gate was. Was it an AND gate? Was it an OR gate? Was it an OR gate? You can determine that by simply observing the truth table. Now, to make this explanation simpler, we're gonna represent this input wire as an A. So every time electricity is flowing through this input wire, we'll say it's a 1. Every time electricity is flowing through this input wire, we also say it's a 1. And when electricity is not flowing through, 0, and this input wire is 0. When electricity is flowing out as an output, we'll say 1. Electricity is not flowing out, 0. So this other logical input will be represented as a B. Then the output will be represented as a C. Now let's draw the truth table for you to get a better understanding now. So since a logic gate, that is the AND gate, takes only 2 inputs, we will only need 4 rows, and you'll see why. So for the columns will be 3. Why are they 3? Because we have 3 distinct ways we can track that electricity flow. So mind you, this is the AND gate. There it is, there it is, and don't mind my drawing, it's bad, I know, but there is an output, there's an input, and there's another input. So this input is represented by an A, this input is represented by a B, and this output is represented by a C. So an A there and a B there. Then we also track the outputs. Since I said the logical AND gate obeys the principle of everything, for it to work, it wants everything. It wants everything and it demands everything for it to work. Just try to remember these terms and don't worry, you'll be in for a safe ride. Now, let's start trying to track these inputs by actually giving the AND gate some input. What do you think will happen when I don't give the AND gate anything? And remember, it wants everything. What do you think will happen? So I say input wire gets input wire A gets a 0. Input wire B gets also a 0. What do you think will happen to the AND gate? And as you can predict, it won't be satisfied and it won't give you any output because you simply didn't give it everything and instead you gave it nothing. So it will produce a logical output of 0. Now what do you think if I give it something? If I say input wire A is equal to 1, like I'm allowing the electricity to flow through input wire A, and input wire B, I don't give it anything. I don't allow any electricity. So 0. What do you think will happen? Well, as you can predict, since the AND gate only gives you a logical output when you give it everything, it won't give you any output. So that's a 0. What about if I switch these values and I said no, it should be this time input wire A is the one which won't get anything, input wire B will get something. The logical output of C will also be 0 again because you didn't give it everything. So always try to remember, AND gate obeys, it wants everything. What about if I give it everything now? Finally, I say, okay, A, I'll give you something. On B, I'll also give you something. What do you think will happen? And when you give it something on A and B, that's when now the AND gate will say, okay, we're now good friends. Let me give you an output. And that output will be a 1. So from that table, you can clearly see the pattern that an AND gate will only be on when both on its input side is given something, like it's given an input on both input wires. So just try to master this truth table, and if you don't master this truth table, I don't even recommend mastering. Just understand that when I'm given everything on the AND gate, that's when I produce an output. When I'm given something or nothing, I'll never produce an output. So that was the last video to logic gates. You don't even need to understand these diagrams and all that. The only thing that you need to remember is how these logic gates are actually performing this logic. So remember that AND always gives you an output when it wants everything. For the OR gate, it produces an output when it's given anything. For the NOT gate, it produces an output when it's given nothing, because this will become essential when we start Java programming, as the same AND or NOT gates are used in Java programming to make conditionals. They are very important topic in Java, as they are used to make conditionals, to make a computer actually make a decision on its own. So that was the last video in the series. If you didn't understand it, feel free to comment, inbox, and join the Facebook group and all that. And please leave a like, share, and subscribe. Thanks for watching.